In this video, I'm going to talk about some aspects of normal distribution. In particular, I'm going to decode the numbers that you see on this bell-shaped curve. That is, we can see mu plus minus 1 standard deviation generally accounts for 68.3%, while mu plus minus 2 standard deviation accounts for 95.5%, and mu plus minus 3 standard deviation accounts for almost 99.7%. Now we are going to understand how these numbers are derived. Let us get started. I have got one variable called x, and I have generated 10,000 random numbers for x, and these random numbers are normally distributed. Let us cross check with the help of descriptive statistics whether these random numbers are normally distributed or not. To do that, I'll go to data, then I'll go to data analysis, then I'll click on descriptive statistics, I'll click on OK, I'll select the input range, let me do it. I'll select the input range A1, Control Shift down arrow, column should be ticked, levels in the first row, this should also be ticked. I'll specify the output range. Suppose I want the output to appear in H1, I should click the summary statistics, then I should click OK. That should give me the descriptive statistics for X. Now you can see these two numbers, that is kurtosis and skewness, and both these values are very close to 0, which signifies X is by and large normally distributed. Now the next thing that I'll do, I'll plot histogram for X. To do that, first I will generate the bin. I'll start with the minimum value of X as the first bin. So minimum value of X is 80.79. Let me just reduce the decimal places to 2 decimal points. Okay, and then we'll proceed. My second bin will be the first bin plus my bin interval, that is, let us take 0.01. I'm deliberately taking a very small interval so that we get the effect of a continuous compounding. The smaller the bin interval we take, better will be the accuracy of the result. So that's how we get the second bin. Once we have got the second bin, we can select the second bin and double click on the plus sign. So this will give us the bin values for other cells in this particular column, right? Once we have got these bins generated, we can now move to data, and then we can go to data analysis, then we can click on histogram, then we can click OK. This dialog box will appear. Now I'll just give the input range. Input range will be from A1, Control Shift down arrow, then I'll give the bin range. So bin range should start from B1, then Control Shift down arrow. So we have got input range, bin range, labels should be ticked because the first item in any column is a label, right? Output range we have to specify. Let us get the output in C1 and we need to click on chart output because we want the chart output. Once all these things are done, we can click on OK. Once we click on OK, we'll get the histogram and chart output. I'll just place the histogram so that we don't have any overlapping to a place where it is comfortable for all of us, right? So I will just expand the histogram a little bit. I'll delete this, right? So this is my histogram and you can see it looks pretty much like a bell-shaped curve, right? And we have got the impact of a continuously distributed curve, right? Or we have got the impact of a continuous distribution. We can very much make that out from the shape of the curve, right? Now what next we will do, we will try and decode these numbers. We'll try and decode these numbers, and for that purpose we need to calculate the probability and the cumulative probability. Now if you see, when we generated the histogram, we have already got the histogram output, right? That is the bin and the corresponding frequency, right? Now what we can do, we can just convert these frequencies into probability. How we can convert the frequency into probability? Very simple. Frequency divided by total frequency. Total frequency is nothing but the count, right? And I'll give absolute reference for the total frequency. And then I'll just simply double click to get the probability calculation replicated in other cells. And if we just scroll down, you can see we have got all the probabilities calculated. Calculation is correct, right? Now let us calculate the cumulative probability. So cumulative probability for the first cell in F column is nothing but the probability, right? And the next cumulative probability number should be calculated as the first cumulative probability plus E3, right? Once we have computed the second cumulative probability, you can just select that and just double click to get the same replicated, right? Once we have got the probability and cumulative probability, then we can just come to these calculations. You can see here I have already written mean plus 1 standard deviation, mean plus 2 standard deviation, mean plus 3 standard deviation, mean minus 1 standard deviation, mean minus 2 standard deviation, mean minus 3 standard deviation, right? And we have already calculated these values for x. I'll just show this calculation fresh so that you can understand. So mean is 100.09. I'll give absolute reference plus 1 into standard deviation. Standard deviation is 5.02. Standard deviation also I'll give absolute preference. This will give me mean plus 1 standard deviation. In the same way, I can calculate the other values of x, that is mean plus 2 standard deviation, mean plus 3 standard deviation, right? But from this value onwards, I'll have to modify the formula because now we have mean minus. So I'll just change the formula and then I'll just drag this for the next two cells, right? So this gives me the x values, right? Now let me show you how I have got these cumulative probability numbers. So let me delete this first and do it one by one. So what I'll do, I will just find out from this column and the bin column the cumulative probability corresponding to a bin value of 105.11. Okay, so let us do that. Now 105.11, let us scroll down. 105.11. So 105.11, 105.11. So here is 105.11 and the corresponding cumulative probability is 0.8407. So let us say that. Okay, so we have got the cumulative probability corresponding to a bin value of 105.11. Next we'll calculate, or we'll find out rather, the cumulative probability corresponding to 110.14. So again let us scroll down. 110.14, 110.14 corresponding to that, this is the cumulative probability. Okay, and the cumulative probability corresponding to 115.16, we can find out 115.16. So 115.16 cumulative probability is 0.9985. Now we will find out the cumulative probability corresponding to 95.06. Cumulative probability corresponding to 95.06. So let me scroll down. 95.06. So 95.06 cumulative probability is 0.16. Done. Next we'll find out cumulative probability corresponding to 90.04. So 90.04. So let us scroll down. 90.04. 90.04. So cumulative probability corresponding to 90.04 is 2.19% or 0.0219. Okay, and finally we'll calculate the cumulative probability, or we'll find out the cumulative probability corresponding to 85.01. So let us scroll down. 85.01. 85.01. 85.01. So this is the cumulative probability, that is 0.0015. Okay, so we have got the cumulative probabilities corresponding to all x values or all bean values, right? Now I can use Excel function also to obtain these cumulative probabilities, but definitely numbers will be little different because all the numbers are random numbers and it is almost impossible to get a data series which is exactly normally distributed. So naturally there will be some differences, but we can very much get the cumulative probabilities with the help of the norm_dist function available in Excel. So I'll be using the function norm.dist open bracket x, that is 105.11, comma mean is 100.09. I'll give absolute reference. Then standard deviation is 5.02. I'll give absolute reference, and I want cumulative distribution, so true, bracket close, press enter, and I can simply drag it for other calculations, right? And you can see by and large we are getting similar values, right? Whether we are using the cumulative probability, that means where we are identifying the cumulative probabilities manually, and when we are using Excel function to find out the cumulative probabilities, right? Now let us try and find out the probability that x lies in between 95.06 and 105.11. So basically what I'm doing, I'm trying to find the area in between x equals to 95.06 and x equals to 105.11, or basically I'm trying to find out the area between mean plus 1 standard deviation and mean minus 1 standard deviation, right? So that's what we are trying to find out. So how we can find that out? It's very simple. We'll have to deduct the cumulative probability corresponding to 95.06 from the cumulative probability corresponding to 105.11. So that's what we have to do. So let us do that. So cumulative probability corresponding to 105.11 is this, minus cumulative probability corresponding to 95.06 is this. So this will give me the probability that the x lies in between 95.06 to 105.11, right? The same way we can calculate the probability that x lies in between 90.04 and 110.14. So that can be calculated using the same approach, that is cumulative probability corresponding to 110.14 minus cumulative probability corresponding to 90.04. Similarly, you can calculate the probability that x lies in between 85.01 and 115.16. and that is equal to cumulative probability corresponding to 115.16 minus cumulative probability corresponding to 85.01. Okay, so this gives us the cumulative, not cumulative, the probability of x value lying within these ranges, right? Correct. So we have got the probability between mean minus 1 SD and mean plus 1 SD, that is 68.07%. The probability between mean minus 2 SD and mean plus 2 SD is 95.45%, and the probability between mean minus 3 SD and mean plus 3 SD is 99.7%. So these numbers or these probability numbers can also be calculated using the norm_dist function. So the similar way we can calculate, that means the probability that x lies in between 95.06 and 105.11 can be calculated as the norm_dist for 105.11 minus the norm_dist value for 95.06. Okay, and if I just drag this down, in the same way we can calculate the other probabilities also, right? Now you see what effectively we have got is what gets reflected in this diagram, right? If you see it, if you see this diagram very carefully, let me just yes, now we can view all the calculation, all the numbers and the diagram as well, right, or the bell-shaped curve as well. You see, according to this bell-shaped curve, mu plus minus 1 standard deviation, mu plus minus 1 standard deviation should be equal to 68.3%. So that's what we are basically getting, roughly 68.3%, right? And mu plus minus 2 standard deviation, mu plus minus 2 standard deviation should be equal to 95.5%. Here mu plus minus 2 standard deviation is basically giving 95.45%, very very close, right? And mu plus minus 3 standard deviation should give us 99.7%. So here also we are getting very close number, 99.7%, right? So this is how we can decode these numbers that we frequently see on a bell-shaped curve, that is mu plus minus 1 standard deviation accounts for 68.3% of the area under the curve, or the probability of the total probability. Mu plus minus 2 standard deviation accounts for 95.5% of the area under the curve, or 95.5% of the total probability, and mu plus minus 3 standard deviation accounts for almost 99.7% of the area under the curve, or 99.7% of the total probability. Hopefully you got it. Thank you.